For this lab, I designed a NAND register by building a circuit to see the effects of set and reset. Afterwards, I examined the results by changing the inputs of S and R in their forbidden states. So currently, both of the LEDs Q and Q0 are receiving zeros for S and R, and as a result, both of them are lighting up. Now, when I change them both to 1, the result is unpredictable, and one or the other will change to a 0. There's no way to predict because if both of them are 1s, Q and Q0 should have the previous results, but the previous results depend on which S or R went first, changed first as in. So if I repeat this multiple times, the results are not consistent. This is because the small differences in timing causes one of the LEDs to change and the other one to stay the same. One of the problems that I encountered was that I needed to use many small wires to keep the circuit concise, but it made it more difficult to place the wires in the right spot. I resolved this issue by moving every wire using a plier to help place the wires in the correct spot, and I also moved my NAND gate down a little bit. So now I can also change so that the inputs of each individual R and S are individual. So now instead of both of them getting 1 or 0, they can have their own inputs that are independent of each other. So now I'm going to check the voltage of across the resistor, LED, and the NAND gate. Across the resistor, the voltage is about 3.41. Across the LEDs, it's about 1.7 volts. And across the NAND gate, it's about 5.13 volts. And the way I approached my design was to make the NAND SR latch using the same design as the NOR SR latch, but just changing the gates. To get the forbidden states, I used a single lever that was connected to both ground and power. The output of this travels to the inputs of the NAND gates, so timing could be closer. Then I connected the output of each NAND gate to the second input of the other NAND gate. The outputs also went to a resistor of 12K volts and an LED so you can indicate if Q or Q0 were on. And in conclusion, the goal of this lab was to construct a NAND SR latch. This was done by using the NAND gates and connecting the output of the NAND to the second input of the other NAND. The first input were controlled using a lever connected to ground and power. This allowed that the S and R to be synchronized when changing between 1 or 0.